Alright, Unit 16, Day 9. As you can see, my voice is back to an extent, so yay, Mr. Houston. Now, on number 1, okay, this is just the factoring view, so there's going to be a mashup of everything that we've done for the last 8 days worth of class time. So, number 1, if we look at this one, first thing that I notice is that both of these are divisible by 5. Okay? Second thing that I notice is that they both have an m attached to it. So I can go ahead and pull out an m as well. Now that's going to be 5m on the outside of, well, whenever we go to divide this 5m by 5m, that's going to be 1. And then 15m squared divided by 5m, well, that's 15 divided by 5, that's going to be 3. M squared divided by m is going to be m. And there's the answer. Alright, next problem. This is one of those problems where a is equal to 1. So, what we need to do is we need to look at this last number in the sequence here. We need to look at negative 28. Okay, now riddle me this. What multiplies to give us negative 28 but adds to give us positive 3? Alright, time's up. 7 times negative 4. Alright, now that's going to be x plus 7 and x minus 4. There's some neat tricks that you should have picked up along the way where you can just jump to that conclusion. Now, number 3. First thing that I notice is that this is not in standard form yet. So we need to go ahead and get it there. It's going to be x cubed plus 3x squared plus 2x. Next little thing that we need to do is we need to get this in, we need to go ahead and factor out a greatest common factor if we can. I notice that they all have an x. So what I can do is I can go x on the outside of x squared plus 3x plus 2. Alright, now where can I go from there? Well, the factors of 2 are 1 times 2. We all know that. So this piece right here is going to break apart into x plus 1 and x plus 2. So x on the outside of x plus 1, x plus 2. Alright, now on to number 4. Let's see what we got here. Now, on number 4, first thing that I notice here is that it is not in standard form. So we need to go ahead and fix that. So we have negative x squared plus 10x minus 25. Alright, now the next thing that I want is I want to get rid of that negative sign on the front. So I'm going to have negative on the outside of x squared minus 10x plus 25. Alright, now what I notice now is that this is a 25. Okay, 25 is 5 squared. 10 is 5 times 2. So what I can actually do is do negative on the outside of x minus 5, x minus 5. Okay, which is the same thing as saying negative on the outside of x minus 5 squared. And there we have it. Alright, number 5. Okay, standard form, yes, but I don't like this negative sign on the front, so I'm going to go ahead and factor that out. So I'm going to have x squared minus 4x minus 21. Alright, now, where can I go from here? Well, I need to find some factors of 21. Let's see. Well, rather, negative 21. So, let's see. If I go, say, negative 7 times 3 or negative 3 times 7. Now, which one of those two am I going to pick? Well, what I should pick is negative 7 times 3, because negative 7 plus 3 is going to be negative 4. So, what I'm going to be left with is negative on the outside of x minus 7 x plus 3. Alright, now that trick only works if there's a 1 on the front, or on that leading coefficient. That's the only way you can make that work. Alright, now, number 6. Okay, let's see, standard form, yes. Okay, a squared, a, nothing. Alright, is there a greatest common factor? Yes, I can take out that 2. So, divide everything by 2. So I got 2 on the outside of a squared minus 9a minus 10. Alright, now let's see. I can do, let's see, how can I get negative 10? I can do 1 times negative 10, and that one will work. So what I wind up with is 2 on the outside of a plus 1, a minus 10. And there we have it. Okay. Get all that junk out of the way. Alright, now, let's just go ahead and move it all the way up. There we go. Alright, now, number 7. Let's see what's going on there. So, first thing that we need to do is go ahead and get it back into standard form like it's supposed to be. So 2x squared minus 5x minus 18. Alright, now, is there a greatest common factor? No, there's nothing that goes into 2, 5, and 18 evenly. Alright, next thing. We need to see if it's a difference of squares. No. Perfect square trinomial. No. So, and there's only 3 terms. So that means that I'm going to be stuck having to do my factoring by AC method. Alright, now, I'm going to multiply my 2 and my 18, and that's going to give me negative 36. Okay, now what multiplies to give me negative 36, but adds to give me negative 5? Well, let's see, I got negative 9 and 4. Okay, negative 9 times 4 is negative 36. Negative 9 plus 4 is negative 5x, or rather negative 5. So, what I'm going to write out is 2x squared minus 9x plus 4x minus 18. Okay, I section it off, and then I'm going to have x on the outside of 2x minus 9, and then on this next piece I'm going to factor out a 2, positive 2 rather, and that's going to give me 2x minus 9. So I'm left with x plus 2, 2x minus 9. Alright, last little stretch here. On number 8. Alright, the first thing that I notice, again, not in standard form, so we need to go negative 2x squared plus 50. Alright, my next step is going to be to remove the negative 2's. Like that. Divide by negative 2, and what I'm left with is negative 2 on the outside of x squared minus 25. Alright, and with that x squared minus 25, that's a difference of squares. And I can go ahead and break that apart really easily. So I'm left with negative 2 on the outside of x plus 5 and x minus 5. And there we have it. Alright, now, number 9. Alright, number 9. We need to start off by looking at it and asking ourselves, is this in standard form? Alright, and as you can plainly see, it is in standard form. Alright, next thing we need to check for is there a common factor? 1, 5, and 3. No, there is no common factor. Alright, next thing that we need to check for is how many terms does it have? Well, we got 1, 2, 3. If you look at that flow chart that we gave y'all, that means that it's going to be either perfect square trinomial, or we can do it via the AC method. Well, it's not perfect square trinomial because that would mean that this or that would have to be a perfect square. Now, what we have to do is try to do the AC method. So 3 times 1 is 3. 1 times 3. And as you know, 1 plus 3 is 4. 3 minus 1 is 2. So neither one of those are 5. So that means that this has to be prime. Alright, now, moving along. Number 10. Number 10, I can pull out a 10x on this one. Alright, and that's going to leave me with x squared minus 4. Okay, x squared minus 4, as we all know, is a difference of squares. So I can go ahead and rewrite this as, let's see, 10x on the outside of, that would be x plus 2 and x minus 2. And there's the end of the problem. Alright, now, number 11. Okay, let's see. Standard form, yes. Greatest common factor, no. Is there, let's see, is it a perfect square trinomial, or a difference of 2 squares? Yes. So the way this is going to break apart is it's going to be x to the 4th plus 1, x to the 4th minus 1. Now a lot of y'all might be thinking, oh well, that's done, problem finished. Well, you're only partially right, because we can go x to the 4th plus 1 and this part can break apart again into x squared plus 1, x squared minus 1. And then again we can go x to the 4th plus 1, x squared plus 1, and break this one apart into x plus 1, x minus 1. Now that problem is finished because this is not a set of squares. This was. That was. Okay? You have to be able to recognize it, okay? So that is the end of that problem. Now, number 12. We got 3x squared plus 2x minus 16. Standard form, yes. Is there a greatest common factor between 3, 2, and 16? There's nothing that goes into all three of those evenly. So, let's see, what else can we figure out? Now, not much else there, so what I'm going to do is I'm going to try to use my AC method. So I'm going to multiply my A times my C. That's going to give me negative 48. And I have to run through the factors of 48 until I find a set of them with a difference of 2. So I've got 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Those are the two I'm going to use. Alright, so I'm going to use a minus 6 and a plus 8. If I use those, I can wind up with my positive 2 in the middle. So that's going to give me 3x squared plus 8x minus 6x minus 16. And then I can go ahead and section it off. It's minus 6x. Alright, and then let's see. I can pull out an x here and here. So that's going to give me x on the outside of 3x plus 8. And then on the second piece, I can pull out a negative 2. So minus 2 on the outside of 3x plus 8. So my final answer for this one should be x minus 2 and 3x plus 8. Alright. Okay, number 13. Alright, let's see. Now, what do I see? I see that we are dividing x squared minus x minus 20 by x minus 5. There's a couple of shortcuts. I'm going to show you all one the long way and show you one with the shortcut. So we're going to go x minus 5 into x squared minus x minus 20. Okay, x goes into x squared, x times x is x squared minus 5x. Let's see, subtract the 2. That's going to be 4x. Bring down the negative 20. Pardon me. Alright, and then x goes into 4x plus 4 times. X times 4 is 4x. Negative 5 times positive 4 is negative 20. And I wind up with 0. So what I'm left with is x plus 4 as my answer. Done. Alright, now, the other way that we could do this is to do this by factoring. So, 6, let's see, how do we factor that? It's 1 and 6, 2 and 3. Oh, okay, so we know that we got a 3. So we know that we got to use that factor. So we're going to go a plus 2 and a plus 3. So those will cancel, and we are left with a plus 2. And there it is. Alright, now, number 15 asks us to find the area of a rectangle if, or rather, it says that the area of the rectangle is p squared plus AP, 8p plus 15. And then we need to find the dimensions of this rectangle. So, let's see. We know that the leading coefficient for this is 1. Okay, so we got a 1 out front. So that means that we need to go ahead and try to factor 15. So we got 1 and 15, and 3 and 5. Alright, so we've got p plus 3 and p plus 5. So p plus 3, p plus 5. So it says, what is the actual dimensions of the rectangle if P equals 10? So it's going to be 10 plus 3, and that's going to be 13. It's going to be 10 plus 5, which is 15. So the area would be 13 times 15, which should be 195. Alright, now, if you don't believe me, and if you need to double check this, what you do is you take that 10, put it back in at the beginning, into that equation right there, the p squared plus 8p plus 15, and see if that one turns out to be 195. If it does, then you did it right and you're set. Alright.